Have you ever wondered where stars come from? In the vast expanse of the cosmos, locked within the nebulae, lie the cradles of stars. Nebulae are immense clouds of gas and dust, often spanning light years across, a canvas of cosmic artistry where the story of stars begins. Picture a nebula, a colossal swirling mass of hydrogen, helium, and dust. It's chaotic and beautiful, like an artist's palette with splashes of color and texture. Amidst this chaos, gravity, the cosmic sculptor, begins its work. It pulls together clumps of gas and dust, initiating a dance of cosmic proportions, a dance that gives birth to a protostar. This protostar is not yet a star, it's a dense, hot core, a cosmic embryo if you will, but it's on a journey to become a star. As it continues to gather more material, it grows in size and mass. The pressure at its core intensifies, and with it, the temperature rises. It's a furnace, a crucible in which the elements are forged. The protostar's core becomes so hot, so pressurized, that something miraculous happens. The hydrogen atoms, under immense pressure and heat, begin to collide and fuse together to form helium. This process is known as nuclear fusion. It's the heart of a star, the source of its energy, its life force. This fusion releases an enormous amount of energy, causing the protostar to shine brightly. It's a beacon, announcing its arrival to the cosmos. This marks the birth of a star. It's a process that can take millions, even billions of years. But once it starts shining, the star can light up the cosmos for billions more. Each star we see in the night sky has undergone this incredible journey, from a mere clump of gas and dust in a nebula to a dazzling beacon of light. And just like that, a star is born, ready to shine brightly in the galaxy. Ever thought about what a star does during most of its life? Well, it enters a phase we call the main sequence, a stage that can be likened to the prime of life for a star. This is where stars shine the brightest and live the longest. It's an incredibly significant period in a star's life cycle, and here's why. The main sequence stage is all about balance and transformation. At its core, a star is a giant nuclear fusion reactor. During the main sequence, the star's core is ablaze, not with ordinary fire, but with the intense energy of nuclear fusion. Here, hydrogen atoms are compressed and heated until they fuse together to form helium. This process releases an incredible amount of energy in the form of light and heat. Yes, the very light and heat that reach us here on Earth, allowing life to exist, are products of this stellar alchemy. Now you might wonder, if there's so much explosive energy being generated, why doesn't the star just blow itself apart? That's where gravity comes into play. The star's own gravitational pull, caused by its massive size, works to hold everything together. It's a constant tug-of-war between the outward push of nuclear fusion and the inward pull of gravity. This delicate balance is what keeps the star stable during the main sequence stage. This stage can last for billions of years, depending on the size of the star. Larger stars burn through their hydrogen faster, leading to a shorter main sequence, while smaller stars can keep the fusion party going for much longer. So, the main sequence is a period of equilibrium and energy generation. It's the star being the best version of itself, lighting up the universe with its radiant energy and providing the building blocks for new stars to be born in the future. So, the main sequence is like the star's adulthood, shining steadily for billions of years. What happens when a star like our Sun runs out of fuel? Well, the end of a star's life is as fascinating as its birth. As the star exhausts its hydrogen fuel, it marks the end of the main sequence stage. But the universe, in its infinite wisdom, has another trick up its sleeve. The star doesn't simply fade away. Instead, it embarks on a journey of transformation, one that will see it expand and change beyond recognition. As the hydrogen fuel dwindles, gravity, that ever-persistent force, starts to take over, compressing the core. The increased pressure and temperature ignite a new fuel, helium. This shift sparks a dramatic transformation. The star, once a beacon of light and heat, expands into what we call a red giant. This isn't just a fancy name. The star actually turns red due to the lower temperature on its surface, and it grows, becoming many times larger than it was in its prime. Even our Sun, a rather average-sized star, will expand to a size that could engulf the orbits of the inner planets, including Earth. But this red giant stage isn't the star's final form. Over time, the star begins to shed its outer layers into space. This isn't a sudden, explosive event, but a gradual, almost gentle process. Layer by layer, the star peels away its outer shell, releasing a beautiful glowing cloud of gas called a planetary nebula. What's left behind is the star's core, now a white dwarf. This celestial body, about the size of Earth, is incredibly dense. A teaspoon of its matter would weigh as much as an elephant. This white dwarf doesn't have any nuclear fusion happening inside it anymore. Instead, it slowly cools over billions of years, radiating its stored heat into the cosmos. From a fiery red giant, the star settles down as a peaceful white dwarf. It's a journey of change and transformation, a testament to the universe's endless cycle of creation and destruction. But even in death, the star continues to shine, offering a glimpse into the fascinating complexities of our universe. But what about the fate of really massive stars? These celestial giants, much like their smaller counterparts, also undergo a dramatic transformation. When they exhaust their hydrogen fuel, they begin to expand, morphing into what we call red supergiants. This metamorphosis is not the end. In fact, it's just the beginning of an incredible cosmic journey. As the red supergiant continues to burn, it triggers a series of nuclear reactions within its core. These reactions involve heavier elements, creating a chain reaction that starts with helium and ends with iron. This process is akin to a cosmic forge, with the star's intense heat and pressure acting as the hammer and anvil. Now, iron is a unique element in the star's life cycle. Unlike hydrogen or helium, iron doesn't release energy when fused. Instead, it absorbs it. As iron accumulates in the core, it starts to drain the star's energy, causing instability. This is where the star's life hangs in the balance. The iron core's growth is relentless. It becomes so dense and heavy that it can't withstand its own gravitational pull. And then, in a fraction of a second, the core collapses, triggering a cataclysmic explosion known as a supernova. This explosion is so powerful, it can outshine an entire galaxy for a brief period. What remains after this stellar explosion is fascinating. If the star was massive enough, its core collapses to a point of infinite density, creating a black hole, a region in space where gravity is so strong that nothing, not even light, can escape its grasp. However, if the star was slightly less massive, it leaves behind a neutron star, an incredibly dense object about the size of a city, but with a mass greater than that of our Sun. In a spectacular supernova, the life of a massive star comes to an end, leaving behind a neutron star or a black hole. This is the grand finale of a massive star's life, a testament to the incredible power and beauty of our universe. So, where have our stellar journeys taken us today? We've traversed the infinite cosmos, delving into the celestial phenomena that is the life cycle of stars. We've explored their birth, their main sequence, and their death. We've seen how the mass of a star determines its destiny, how the cosmos is a stage for their dramatic life stories. Our journey began with the birth of stars, a process ignited in the dense and cold molecular clouds scattered across galaxies. We learned how these clouds collapse under their own gravity, giving rise to protostars. We've seen the transformation of these protostars into main sequence stars as they lit up the cosmos with their radiance, fueled by the nuclear fusion of hydrogen into helium. In the main sequence, we've witnessed the stars in their prime, shining bright and stable for billions of years. We've learned how this stage is the longest in a star's life, where it spends the majority of its existence in a delicate balance between gravity pulling inwards and radiation pressure pushing outwards. The inevitability of death was our next stop. We discovered that the fate of a star is contingent upon its mass. Small to medium-sized stars, we learned, end their lives as white dwarfs after shedding off their outer layers as planetary nebulae. The more massive stars, however, meet a more dramatic end. They explode as supernovae, seeding the universe with the elements that give birth to new stars, planets, and even life. We've seen how the cosmos is a constant cycle of birth, death, and rebirth. The death of a star doesn't spell the end, but rather the beginning of something new, a cosmic recycling process that keeps the universe dynamic and ever-evolving. The life cycle of a star, much like our own lives, is a journey of transformation. Stars, despite their distant and untouchable nature, are not so different from us. They are born, they live, and they die, leaving a legacy that transcends their existence. From birth to death, the life cycle of a star is a cosmic journey of change, transformation, and ultimately renewal. We hope you enjoy our video, and if you want to know more interesting facts on more different topics, then please show us some love with a like, share, and subscribe. Thank you and have a nice day.